coming on questions on this first derivative test. Simple question, not a difficult one. Find all the points of local maxima and local minima. Question is, find all the points of local maxima and local minima for the function fx is equal to x cubed minus 6x squared plus of 9x minus 8. This is the question we have. Function is given x cubed minus 6x squared plus 9x minus 8. Find where this function is local maximum, where this function is local minimum. Also find out the values. They will ask value also. You find out, we'll do that. So whenever they ask local maxima or local minima and we are taking first derivative test, so I should take first f dash x. Derivative I'll be calculating. What this will come? 3x square minus 12x plus of 9. And then 3 will be common. Left is x square minus 4x plus 3. Or I should say 3 times x square minus 3x plus of x. Minus of x plus of 3. Or I should say 3 times x minus 3 into x minus 1. This is the derivative I got. After getting this derivative, what I should say, for possible points of local maximum or minimum, f dash x has to be 0. If you want the point to be local maximum or local minimum, your derivative has to be 0. And if this derivative has to be 0 means this is equal to 0 next step. This we have calculated and this derivative is coming 0. And if it is coming 0, what does it mean? That shows x is coming 3 or 1. So 2 points we got, x is 3 and x equal to 1. These are the 2 points we have where the function can be maximum, can be minimum, can be a point of inflection also. So we have to check whether it is maximum or minimum. For that, now we should think about our derivative and where it changes sign plus 2 minus, minus 2 plus or does not change, we will decide according to that. So now f dash x we have already 3 times of x minus 3 into x minus 1. So what I do in this case, this will be our number line. This is the derivative we have. And points which you got is 1 and 3. X is coming as 1 and x is coming as 3. These are the 2 points, 1 and 3. And now we have to check where this point is. Point is local maximum or local minimum. We should find out. When you take less than 1 value, less than 1 can be 0. Put it here in f dash x. When you put it 0 here, what you will find, this has come out to be minus. ये भी minus आएगा, so minus and minus net come out to be plus. Then we go between 1 and 3. When you go between 1 and 3, example can be taken 2. When you take 2, it will be coming out to be minus, but this will become plus. So net come out to be minus again. Then we go above 3. Above 3 when you take, it will be 4 I'll take, and it will be plus and it will be plus, so it will be indicating plus. Now, what you will find, x is equal to 1 and x is equal to 3 are the points where already the derivative is 0. So first condition already satisfied. And now what I should say, when you have x is equal to 1, your dy by dx changes from plus to minus. As it is changing from plus to minus, x is equal to 1 is the point of local maximum. And at 3, dy by dx changes from minus to plus, we will say it will be local minimum. So what I should say now, at x is equal to 1, f dash x changes its sign from positive to negative. F dash x changes its sign from positive to negative. Therefore, what I should say, fx is, therefore, x is equal to 1 is the point of local maximum. X is equal to 1 is the point of local maximum. And if they ask what is that maximum value, so then what I should do? We should find out local maximum value. So we will say local maximum value, if you want, that will be equal to what? F1, function's value. So I put in x as 1. What it will come? 1 minus 6 plus 9 minus 8. 6 and 8, 14, and this is 10, so it will come out to be minus 4. This is our local maximum value. Second thing, when at x is equal to 3, I'll take. F dash x changes its sign from negative to positive. X is equal to 3, f dash x change its sign from negative to positive. So we will say x is equal to 3 is the point of local minimum. And if it is local minimum, then local minimum value if they ask, that also I can calculate. It will be f3 will do here. What changes will be here? This will be 27, 9, 6, 54. Plus 9, 3, 27 minus 8. 27, 27, 54 get cancelled out. Your result is coming minus 8. So local minimum value come out to be minus 8. Second question right now, please. Find the point of all the points of local maxima and minima for the function fx is equal to x minus 1 whole cube into x plus 1 whole square. Find all the point of local maxima or local minima which you have here. Please find out what is the point of local maxima and local minima here. Yes, please. First we go for the derivative. So first is f dash x. What that will come? 3 times x minus 1 whole square into x plus 1 whole square. And second one comes out to be x minus 1 whole cube into 2 times x plus 1. 3 times x minus 1 whole square, x plus 1 whole square remain as it is, plus x minus 1 whole cube into 2 times x plus 1. Further simplification, what is common here? We have the common x minus 1 whole square. We have x plus 1 common here. Then left is what? 3 times x plus 1. And here it will be 2 times x minus 1. And now when you solve it, x minus 1 whole square, x plus 1, this come out to be 3x plus 2x. Is it 5x? Yes. Plus 3 minus 2 will come out to be plus 2. So I got it x minus 1 whole square into x plus 1 into 5x plus 1. This is the f dash x we have. Now to get possible point of local maxima or minima, to get possible points. of local maximum or minimum. F dash x has to be 0. And when you have f dash x is equal to 0, it means what I should say? X minus 1 whole square into x plus 1 into 5x plus 1 coming 0. And if it is coming 0, what I should have on the number line? One point is 1 here, another is minus 1, and another is minus 1 by 5. So minus 1 is here, minus 1 by 5 is here, and 1 is here. Minus 1 by 5, and 1. These are the 3 points we have on the number line. After getting this on the number line, now just check what the values comes. When you take less than minus 1. When you take less than minus 1, what this will be? Maybe minus 2 I'll take. This is already plus because of whole square. Minus 2 plus 1, it is minus here. And then it will be minus 10 plus 1, again it is minus here. So minus minus plus, net will be plus. Then we have between minus 1 to minus 5. Here it is minus 1, here it is minus of 0.2. So 0.5 will come somewhere here. When you take minus 0.5, it will remain plus. Minus 0.5, it will remain plus here. But this will become 2.5 minus, and this is plus, so it will be net minus. So plus, plus, minus, it will be minus. Then I go between 0.2 and 1. Will it come 0 here? When you take 0, it will be 0 here, it will be 1 here, it will be 1 here. So will it be plus? Yes, all 3 plus here. And above 1 when I take, this is also again coming plus. For example, 2 I take, it will be plus, 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 so it will be plus. So what you should say now, at x is equal to minus 1. Dy by dx, or you should say f dash x, changes its sign. From positive to negative. X is equal to minus 1, dy by dx changes its sign from positive to negative. Therefore, what I should say, x is equal to minus 1 is the point of local maximum. Clear? Second one, minus 1 by 5, it changes from minus to plus. So when at minus 1 by 5, dy by dx changes its sign from negative to positive. So we will say therefore x is equal to minus 1 by 5 is the point of local minimum. What about 1? Yes, anyone?
So it is the inflection.
Yes, it is a point of inflection. So x is equal to 1 is the point. What you will say? Where dy by dx does not change its sign. It does not change its sign, so we will say it will remain plus 2 plus. So x is equal to 1 is the point of inflection. That you should give it. Next question, please. Find all the point of local maxima and local minima where fx is equal to x cube minus 6x square plus 12x minus 8. Find the point of local maxima and local minima on this. Where this is local maximum, where this function is local minimum, find out. So for that, again, f dash x, when I take, what this will come out to be? It will come out to be 3x squared minus 12x plus 12. 3 I'll take common, left is x squared minus 4x plus 4. Then I should say 3x minus 2 whole square. And then we say for possible point of local maxima or minima, it should be 0. For possible point of local maxima or minima, this has to be 0. And when this has to be 0, we will get x is coming 2. X is coming 2 here. So when you got x is equal to 2, now we should check where this dy by dx changes its sign. Here when you have x is equal to 2 and our function f dash x we have as 3 times x minus 2 whole square. This part if I take, always remain plus here, so I'll say this side you take or this side you take, it will come out to be plus every time. That means we will say x is equal to 2 is the point where function does not change its value. It will remain from plus to plus. We will say yes, it is the point of inflection. So therefore, x is equal to 2 is the point of inflection. X is equal to 2 we call as point of inflection. It is the point of inflection we have. X is equal to 2 because dy by dx does not change its sign. It remains from plus to plus. We will say it is the point of inflection. So keep in mind now this function can give a local maximum point, local minimum point, or point of inflection. One more question right now, please. Fx is equal to sin x plus cos x. Fx is equal to sin x plus cos x. And whenever this function, there must be some interval given in the question. X will be, in this case, it is between 0 and pi by 2 given. My question is find out where this function is maximum, where this function is minimum. Local maximum, local minimum, we should